my name is Meredith, and I'm very pleased. Thank you for the introduction. Pleased to be here. I'm going to be talking about Anvil, which is a platform for building web apps with nothing but Python. And before I get into the nitty-gritty of how it works, you might want to ask, why? Why is this a thing we want to do? And I will argue to you that the way we build web apps today, most of the time, is pretty broken, right? Just think about it from the point of view of your data. Right? Your data probably starts as rows in a database table in a typical web app. You access it via SQL. You then read those from a database, turn them into objects on your server, probably in Python in present company. And they have methods and attributes to access them. But then, of course, you don't leave them as objects. You immediately turn them into JSON and send them over REST, over HTTP with this very limited set of verbs, get, post, put, delete, and so on. And then at the other end of that HTTP connection is some JavaScript, which is going to reassemble that into different objects in a different programming language with methods and attributes on their own. And then we have to transform that into HTML DOM for the browser to render. And then we use CSS to turn that into pixels. And that is a lot of different representations of your data. And there's a lot of transformation levels there. And all those transformations are tedious and repetitive. And what's worse than being tedious and repetitive is that they attract the wrong kind of magic. What do I mean by the wrong kind of magic? I'm going to illustrate by taking a totally unfair pot shot at SQL Alchemy. Who in this room has used SQL Alchemy? Yeah, OK. Right, for those of you who haven't, it's a library for representing rows in an SQL database as Python objects. And this is an unfair pot shot because this is actually really cool. It lets you write expressions like this, right? Filter, book.price is less than 20. That's nice. But of course, transforming that Python expression into SQL you can run against a database is black magic. We are talking meta-classes. We are talking overloading ordinary Python operators to do something completely different to what they normally do. If you think that's a numerical comparison, you're in for a surprise. That is generating source code in a different programming language. And that's OK if you do it once. But if you have this level of magic at every layer of this stack, you are going to have a bad day. And of course, that's exactly what we do, right? We have ORMs like SQL Alchemy turning database rows into objects. We have REST frameworks helping us represent those objects over HTTP and JSON. We have JavaScript frameworks like Angular's resources turning those HTTP requests back into objects. We have templating engines to turn those objects into HTML DOM. We have CSS frameworks to turn those things into pixels. And every layer of those is the wrong sort of magic. It abuses the semantics of one layer to represent an adjacent layer. You need to learn it all, and it is brittle. I mean, we're Pythonistas here, right? How does that stack up against PEP20, the Zen of Python? Simple is better than complex. That is not a simple system. If the implementation is hard to explain, it's a bad idea. Like, the insides of JavaScript frameworks are famously gnarly. They are not easy to explain. Here's a famous one. There should be one and preferably only one way to do it. Oh boy. Right? So, if the way we do web development is a mess, how should we do it? Well, this is what we do. We take all of these nasty frameworks and we replace them all with Python. So what we have is a visual UI builder where you can drag and drop components and you represent them as Python objects. Client-side code in the browser is written in Python. We translate that into JavaScript, so you can just access your UI. You don't need to generate source code in a different programming language. You represent your UI as objects. Python on the server, of course, but if you have Python on the server and Python on the client, there's no reason to mash everything into JSON just to get it from one to the other. No, it's just a function call. We even have a Python native database so that you can access the database rows and tables as Python objects. So you can take a row from the database all the way from the database to the visual UI without having to change its representation, and that is very powerful. All right, so that's the idea of how it works. Let me show you what it looks like in practice. OK, let's switch over. So here I am in the Anvil editor. I'm just going to show you, start by building like a simple Hello World app. So I'm creating a new app. I've chosen my visual theme. This here is a web page. And over here is a toolbox of things I can put onto that web page. So I'm going to put a title on by dragging a label, which is a component that displays some text, up into the title. I can then edit its properties. I can say its text should be Hello World. And that's how I put some text onto my page. All right, let's do something more exciting. I'm going to put a card on here. I'm going to so what we're going to do is we're going to have an app where the user enters their name. And we display a personalized greeting. So I'm going to add an input box so that they can answer that question. Oh, hang on, we're going to give this a name. This text box, we're going to call name box. Everything in Anvil has a name, so we can access it from code. We're going to have a button in here for them to click when they're done. Oh, no, not there. In here. There we go. OK. Say hello. And we can make this a bit more prominent. And you can see what's going to happen, right? They're going to enter their name, click a button, and a message is going to appear. So our last thing is going to be a label for that message to appear on. I'm going to call it message label, because I lack all creativity. And we can say this is going to be centered and make the font size big and so on. So we've just built a web page, and that's an awful lot faster than you could have done it in HTML and CSS. But the really cool thing is that every part of this is backed by Python. So if I double-click this button, I'm editing the Python code that runs when that button gets clicked. And you can see all the things I dragged and dropped onto the screen are available as variables in my Python code. So if I want to change the text on that message label based on the text that's been entered in the name box, I go self.messagelabel.text, hello, self.namebox.text. That's it. OK, so we've just built a web application in a very short period of time. In fact, it's already live online. Let me try pointing this slightly more towards myself. It's already live online. This is its URL. This is like one of those Google Docs URLs. So if you don't have the URL, you can't access it. But I can set it as public. Hello, PyConSK. OK, you could go to hello-pyconsk.anvil.app on your phone or your computer right now, and that app is live. We have built and published a web app in, actually the timer stopped. Someone could start that iPad screen again. I don't know exactly how long, but it was not long. OK, so that's fine. But this all happens in the browser. Remember, this Python actually gets compiled to JavaScript and runs in the web browser. And any serious application is going to need some server-side code as well. So what do? Well, we can add server modules. And this is an ordinary Python module that happens to run on our server. Ordinary Python module, ordinary Python function. Takes a name parameter. Nope, I can't spell. Can people read that? Hands up if you can't read it. OK. Better? There we go. OK. So what we do, this is an ordinary Python function, but we tag this anvil.server.callable. And we say, so this says this function on the server, we should be able to call it from the browser. So if we go back to our client-side code, as well as updating the UI, we go anvil.server.call. And we call this sayHello function. It has a parameter name, so we pass in the text from this name box. And now if we run this, and I enter my name, you can see we've got something in the output in the log file. So now we've got some code running on the server being driven by this Python user interface we've built. And sure, this is kind of limited, right? There's only so much we can compile to JavaScript. You can't open files and so on. But this is a real I'm sorry. This is a real CPython 3.7 running on the server, and it's got the full set. You want to act as a database, import PyMySQL, import PyMongo, connect, go. I want to do some numerical processing, import NumPy. I want to plot a graph, import Matplotlib. It's, batteries included. In practice, the first thing everybody asks is, how do I access a database? So we actually have a database built in. You don't have to use it, but you can. This is backed by Postgres, so this is not a toy. You can put terabytes into this thing if you want to. Today I'm going to do something slightly less exciting. I'm just going to store all the names that get entered. So we'll want a text column for the name, and we'll want a date time column for when it was they signed up. And that's it. I've designed our database. This table is apptables.visitors. So it's accessible from our code in exactly the same way as those text boxes and buttons were. So if I go into the server code, as well as printing this into the log file, we can take apptables.visitors and we can add a row to it. We fill out the name column with the name that's been passed in. We fill out the when column with datetime.now. I've got to import that. And now if we run this, we go to the database, you can see we've recorded those names. So we've just built and published, remember this is online, you could use this from your phone now, we've built and published a database-backed web application in Python in a very, very short space of time. I'm going to show you one more thing before we get on to showing you how it works underneath, which is how you display data back from the database. So remember, we could just return rows from this database all the way to the client. So if we want to display a table of who's entered their name before, we just make a callable function, get visitors, and we have it return apptables.visitors.search, which is, if we don't apply any query, it's going to return everything. And then if we go back to the UI, go back to our design, I'm going to add a data table here, data grid, and it's going to have one column for the name. It's going to pull the name column out. It's going to cover column for when entered. The key is going to be when. And we don't need this third column. We can adjust these and so on. Okay, so in this grid is something called a repeating panel. And a repeating panel is a neat component that has got a property called items, and you give that anything you can iterate over in Python. And once you set the items, it will repeat this template for every element in that list. So here in the init method, we can set the repeating panel's items to the return value of the getVisitors function. And now we're displaying data from our database on our page. Simple as that. One last thing. This date's kind of ugly, right? We're taking a stir of a date time, and that does not look good. We'd like to, to format that date nicely. So we go and we edit the template. And instead of the default thing for that column, we put a label in here. And then we set the data bindings. This is, of course, just a Python expression. So self.item is a row from the visitor table. That is our database row. It's been passed all the way from the server to the client. We can just pull out the when column. And, of course, that's a date time. So we can call the standard Python library functions. So if we run this now, we formatted the date. And excellent. Oh, someone's been trying our Unicode support. Bravo to you. So you can see I've just built and shipped a database-backed web app in a very short period of time, and you've used it so you know I am not lying. So let's see if the remote mic's working. I'm now going to talk a little bit about how that works behind the scenes. So if someone could pass me my water bottle, that would be great. So I'm going to talk this is sort of a set of mini tech talks about how parts of Anvil work underneath. Thank you. I'm going to start with compiling Python to JavaScript, because this is obviously one of the major things. If you want to write your full stack application with nothing but Python, then you're going to need to run code in the browser. And if you're running code in the browser, it has to be in JavaScript. So we need to somehow translate Python to JavaScript. Thankfully, there's an open source compiler called Sculpt. It's a Python to JavaScript compiler. And it does what you'd expect. You feed it a Python expression, and it will produce a JavaScript expression that does the same thing. You feed it a Python function, and it will produce, honestly, it will produce the ugliest JavaScript function you have ever seen, but it will do what that Python function does. And this is great, but there is one problem. JavaScript, in its infinite wisdom, is a 100% non-blocking language, right? You cannot block partway through a function to go, check a database or fetch something from the web. And, you've seen me doing blocking operations, right? I've made calls to the server and then just used the return value. I haven't had to use callbacks, and that's something we'd like, right? Get a more concrete example. Here is an API you might easily write in Python, right? You get something from a database, and then you perform some computation on it. Here is what that looks like in JavaScript. I count 1, 2, 3 nested callbacks, and in case somebody thinks I'm being unfair to JavaScript here, this was copied and pasted from the first page of the Postgres JavaScript documentation. But we have a Python to JavaScript compiler, so we could translate that into that automatically, right? So let's git clone and get going. It turns out that Sculpt has a classic compiler architecture based, unsurprisingly, on CPython. So what you do is you take a Python expression or module. It then breaks it up into bits of text that correspond to sensible units in Python. These, by the way, these JavaScript file names, that's the source within the Sculpt compiler if you want to follow along at home. And then it assembles this into an abstract syntax tree, which is a tree of operations that represent, things that we would think make sense in Python. So, here it's an assignment. The thing we're assigning to is a variable called result. The value we are assigning it from is, it's a function call. We're calling the function called f, and we're passing these arguments and so on. And then there's a compiler that walks over this tree, emitting JavaScript. So it's pretty clear that this is the thing that we're going to have to modify if we want to support blocking execution. So remember that this compiler has to produce a JavaScript function for every Python function, which means that it has to return. So what we do is we invent a new return type, and we say that if the JavaScript function returns something of this type, then it's saying, I've returned, but I'm not done yet, I've just blocked. And we call this type a suspension. And so what we do is, how we compile this call is we make the call, and then we check, is the response a suspension? If the response is a suspension, then we save all our temporary variables, we save all our local variables, we save where we are in the function, we wrap that all up in a suspension of our own, and then we return that. So here's how that looks in a slightly more real-world example. So we've got this button one click function. It's calling get, which is calling into the database, and the database is blocked. It has to go back and get some data. So get realizes it's been given a suspension. It saves its variables, saves its temporaries, it saves where it is in the function, and then it returns that as a new suspension that wraps the inner one. Button one click, again, the generated code realizes it's been given a suspension, so it saves its locals, it saves its temporaries, and it returns a suspension of its own. And then the JavaScript sits on it because we've finished executing. Of course, a few milliseconds later, the database comes back and says, got your data. And so the JavaScript resumes that suspension, which jumps to the right place in the function, restores all the locals, restores all the temporaries, and then resumes the suspension, which jumps to the right place in get, restores all its locals, restores all its temporaries, calls into to resume the database call, which of course returns immediately with the data, and now we're back to normal execution. And that's how we turn blocking Python into non-blocking JavaScript. Yes, sculpt.org is the website. We are always looking for new contributors. I'm one of the maintainers. please do get in touch if you want to join in. Here's another thing you saw me doing out there. I was making these calls from client to server, right? Just managing to skip, in an ordinary web app, that would be like routing and REST endpoints and JSON mashing. Here, it's just a call. We go anvil.server.call. We give it a function name, and we give it some arguments. It's a Python call. We've got positional arguments. We've got keyword arguments. We've got return values. And, well, how do we do that? So it's blocking, so it uses suspensions, obviously, if you're in the browser. What we actually do is we do a remote procedure call over WebSockets. And we encode the arguments and the return values as JSON. Which is fine for the values you see there, right? These are all JSONable values. But what about values that aren't JSONable, right? You saw me throwing database rows around there, just, like they were ordinary return values from a function. This is obviously something we want to do. And the question is, how do we do it? Okay, just another illustration. We have something in the database. We want to get things out of that database. And we want to be able to return those values all the way back to the client as simple return values. So the way we do this is we have a concept we call live objects, this is a type of data that you can pass to and from these server functions. And the important things about live objects is that they represent a server-side resource. So, any client-side state is just cache, right? That object is the database row. They have to be secure, because just because we're allowing the client code to call methods on a database row doesn't mean that the client code should be able to call methods on any database row. Otherwise, every visitor has access to our whole database, which isn't exactly what we wanted. So what we do is we adopt the rule that possession is permission. So this is, in computer science, we call this a capability model. The idea is that if I've been given the object, then I have access to the object. So if I've returned that object from a server function to the client, that was me giving permission to the client code to access it. And what this means is you don't have to manage your permissions separately from passing these objects around. So this is how it's actually implemented. So every live object has an identifier. This is this table, this row. It's got some methods we can call on it, update, delete, a get item, which is, lets you access things as square brackets, set item, and so on. And, of course, a set of permissions, in this case, read-only. And then what we do is we take a digital signature over the whole live object with a key that is known only to the server. And so every time we send a live object to the client, it's signed. And when the client passes a live object back to the server, then we can check the signature. And if the signature matches, then we know that must have been an object we gave it. Because, if it didn't come from us, the signature wouldn't be right. It's not non-forgeable, we say. And so this means that we can safely give these things to the client, have them pass back, and trust what the client is giving us. So here's what the API ends up looking like. This is a simple server function. We're looking for a person with a given name. We check whether we are logged in using the Anvil built-in user authentication system. I don't have time to show you, but it's awesome. And we return we get a row from the database, and we return that only if the user's logged in. And of course, on the client, that means we can just call the getPerson function. We get this database row, and we can call methods, in this case, getItem, on that row. Again, right, the server has chosen whether to return it with that if statement. So we've applied security, but that's the only, we didn't need to do permissions separately. We just chose whether to give you that object. We can, of course, be more clever than this. We can set permissions. So we don't have to be read-only all the time. This function returns a writable version of that database row. So it takes the apptable.people table, it takes a client writable version of that table, and then it searches that. And so the rows you get from that are going to be client writable. And so if you get this in the client, you can get this person value, and you can just increment its age. So this means that we can edit the database from the browser. We can edit the database from the code that handles button clicks. In a traditional web application, every operation you want to perform, you need to implement it at every one of those 5 layers. Sorry, 6 layers even. And here, we can just do it from our button click handler. That's going to save you a lot of work. We can get even cleverer still. We can return views on tables, because of course data tables are live objects too. So, here's an example. So we get the current user. If we are logged in, we get a client-writable view of the records table, but only of the rows where the owner is the current user. And what that returns is something we can use like a data table, right? We can get this records object out, we can add rows, we can search it, we can delete things, but we can only add rows with that value in the owner column, and we can only search rows with that value in the owner column. So we've just delegated a whole chunk of our database to client code for it to operate on directly, and there's a huge number of operations we just don't even have to write server things for. And again, it's because we've got this capability model that lets us delegate permission to the place where it's most convenient to write the code, rather than writing the code where it's most convenient for the framework. Okay, I'm going to finish by talking about, frankly, this is my favorite little mini tech talk about Anvil. This is about the autocompleter. So you saw, as I was typing in that demo there, it was code completing everything I wrote. And this is really, really important, right? Autocompletion is great. Hang on. Hands up here who uses something like PyCharm. Okay, hands up here who are the Emacs and Vim diehards. Hey, okay, a few of you. Right, so I'm mostly preaching to the choir here, but I will say it, autocomplete is great. Autocomplete is great because it gives you discoverability. It lets you discover what's in an API without having to check the documentation every time. It gives you speed because you can hit 3 letters and hit the tab key. It gives you confidence that what you're doing is right, because there are whole classes of bugs that you can eliminate without even hitting the run button, because the autocompleter has warned you that, that's not how you spell that word. Or, this variable wasn't the type you expected it to be. And for all those reasons, it feels good to use. Confession, we originally built Anvil without autocomplete. We thought we could get away without it. I'm here to tell you we were wrong. Autocomplete is essential. And if you are one of those diehards who put your hand up and you're still using Emacs or Vim or something that doesn't have autocomplete, I beg you, get Jedi as a plugin or any of the similar plugins you can get. Just do, if you remember nothing else from this talk, do me a favor, try it for a week. It will change your life. Unfortunately for us, these off-the-shelf autocompleters weren't quite sufficient. A couple of reasons. One is, of course, that Anvil's full stack, so we need your autocompleter to know about your database, and know about your server code, and know about your client code, know about what things you dragged and dropped onto that editor, which, I mean, we could have patched that in, but the real issue is that Anvil is, of course, in the web browser. And when you're in the web browser and you're hitting the tab key, there is just not enough time to go back to the server, parse all your code, come up with autocompletions and send them back. So we ended up having to implement our own in JavaScript. So here I am opening a Python conference by talking about my JavaScript project. Please don't throw anything at me. Conveniently, of course, this would be a really daunting undertaking, except we've got a Python to JavaScript compiler lying around. So you've already seen how we can use Sculpt to turn a Python module into an abstract syntax tree. And that's exactly what we do. So when you hit the tab key, we replace your cursor with a random symbol, and then we throw the whole thing into Sculpt. And it comes out with an abstract syntax tree. And we can then recursively walk that tree and build up a representation of all the variables that are in scope at every point in your code. And then when we hit the name node containing our magic cursor symbol, we go, well, what are all the variables in scope? We can offer those as our completions. Of course, variables aren't the only thing we can complete, right? You saw me when I was accessing the database rows, right? We were auto-completing the items available in getItem square bracket lookups. In fact, there's a bunch in this because here we're auto-completing the attributes for apptables.users.search. We're working out what types you get when you call that function. We're working out what type you get when you iterate over that result, and then we're pulling out the possible square bracket lookups. Speaking of function calls, of course, you don't just want to know what type a function returns, right? You want to be able to autocomplete its arguments as well. And of course, we want to do it across server and client, which is another thing that traditional web stuff can't do, which is why we're missing autocomplete in the world. We had autocomplete in the 1990s, and now all these web developers are doing without it because the environments can't work out what the server's doing. Anyway, here's an example, right? We have a server function called sayHello. We're passing a dictionary into it, and we really want to be able to autocomplete the arguments in this. And so how we do this is we actually, when we're parsing a module, as well as keeping the top level scope of that module, so that's all the functions and classes and so on that are defined, we can, because we need that because that's what you get if you import that module. We also store all the outbound calls. So we store all the function calls that module makes. And that means that when we parse that client module, we store that function call, and when we're parsing the server module, we go, oh, we're parsing the sayHello server function. We know what arguments that gets called with, and so we pull that out, drop it into the local scope where it autocompletes. We autocomplete an awful lot about Python types, and this leads to a rather philosophical question about what exactly a type is. Because you could say, oh, well, the type of a Python object is its class. But we all know Python's a more dynamic language than that. We can, you can dynamically add attributes onto individual object instances. And even when two things are the same class and you haven't done something like that, I mean, are these two variables the same type? We certainly want to autocomplete them differently. So what we do is we actually say, kind of forget about the class of these objects. We duck type our autocompleter. As far as our autocompleter is concerned, these two things are two different types, and they will be autocompleted separately. Obviously, they share a bunch of methods, but they are two different types. So I would like to, oh, you know what? I'm going faster than I thought. I'm going to demo the thing that I was really sorry I had to miss out. This is something called the uplink, and I'm doing this specially for Jan, who wanted to do something with hardware. If you write these server modules in Anvil, you didn't notice I didn't have to run anything, I didn't have to set anything up. It all ran in our servers, which is great for getting something running quickly, but sometimes you want to run your code somewhere else, right? You might be doing a big machine learning job, you want to run it on a machine with 20 GPUs out there in AWS, or maybe you're working with individual hardware. And we have a way of doing that. You can connect your Python code running anywhere to Anvil, and how we do this is something called the uplink. So this is a library you can pip install anywhere in the world. And if you enable it for your app, you get an uplink key. And if you call anvil.server.connect with that key, from wherever your code is running, your code is part of the Anvil app. And you can do all the things you've just seen me do in server code, you can do from wherever your code is running. You can make callable functions. You can access data tables. You can call other functions. The works. So let's show it to you. We want to this code. So what I'm going to do is I'm going to fire up a Python interpreter. Nope, that was not what I wanted to do. Try that again. Oh, I see. Right. So, okay, get into a virtual environment. Pip install Anvil uplink. Of course, it's already installed in this environment. Let's start a Python interpreter. Ooh, we're in Python 2 today. Okay, fine, whatever. So I've called anvil.server.connect. I've connected. We are authenticated. We are now part of this app. I can define a function. I'm calling it say hi. Okay, so just a simple function that's running on my machine. I have defined it on this laptop, on this podium. And now, if I edit this code, when you click the button, instead of calling say hello, I call say hi. And I run this. We've just run code on this laptop from the cloud. And anybody else who's still got that app open on their computers can make something appear on my terminal right now. And of course, you can use this. You can use this on a server somewhere out there running beefy compute jobs, or you can use it on a Raspberry Pi that's controlling your curtains or controlling an industrial process. Okay, that was my indulgent side part. So I've shown you a few things about Anvil and how they work underneath. And before I stop and take questions, I'd like to finish by talking a little bit about the why of Anvil, the design philosophy that's guided everything I've shown you so far today. And there are two big principles involved here. The first is that code is good. We are telling a computer what to do. And in nearly a century of working with computers, humanity has found the best thing we have is writing text in a programming language. You will periodically encounter something that will say, oh, you can write write apps without writing any code. And this is nearly always a false promise. You'll end up with a system that won't support all of what you need, or worse, you will find yourself in a tangled up in flowcharts, shaking your monitor, yelling, "Let me write the blasted for loop." And so we let you write the blasted for loop. Get you to the code as soon as possible. Even in the UI designer, do you remember right back at the beginning when I was building that table of previous visitors and I was formatting the date for when the user had signed? I wasn't dragging and dropping some wibbly line from a database. No, I wrote a Python expression, even in the visual designer. And what that meant, of course, was that I had all the power of the full Python libraries at my fingertips. Get me to the code. Code is good. The second big principle is that we need to be accessible. I've already ranted a bit about how the web isn't accessible, but let's be clear. We need to be simple enough for novices. It is frankly a disgrace that the greatest application delivery platform on earth, the web, you need to learn 5 different programming languages just to get started. That is not acceptable. We need to be simple enough for novices to use. But that's only half of accessibility, because to be properly accessible, you need to be simple enough for novices, and you need to be powerful enough for seasoned professionals. This is partially for the novice's benefit, actually, because if you say, oh, here's something that's easy to use, but you're in the kiddie section, you're in the playpen, then you've stopped those people growing. You need to let them grow their powers. But also, seasoned professionals, we need some love too, right? Just because I can write 5 different programming languages doesn't mean I want to. And it certainly doesn't mean that my boss wants to wait for me to do it. And you might look at this and think, yeah, sure, but these are incompatible goals. And I want to say that that is wrong. And it should be obvious to everybody in this room that that is wrong, because Python does it, right? The reason that we are all in this room, the Python programming language, is the first thing that you will show an 8-year-old in their first lesson with a Raspberry Pi. And it's what Instagram use, and it's what Google DeepMind used to beat the human brain at the game of Go for the first time in history. Python shows us it is possible for something to be simple enough for novices and powerful enough for seasoned pros. And it is only the garbage fire of traditional web development that makes us doubt it. Thank you very much. Before I go into questions, I will go for a brief plug. If you're interested in what you've seen and you want to get hands-on with this, we are leading a workshop at 13:10 today in the Hall B. I'm not going to try to pronounce that because I'm going to butcher the Slovak. My apologies. But please do come in and join and see what it's like to actually use. All right, time to move on to questions. Should I just read these from the...
If I may do that. Those are some fantastic words that I concluded with. You know, why should we learn 5 different programming languages just to work on the biggest platform? And yeah, Python is an excellent example of showing something can be both simple and powerful. There are a couple of questions that you have received. The one with the most upvotes. This appears to be a proprietary closed framework. Why would I rely on a non-open source, albeit very exciting product? Seems very risky. Try to convince me.
Right, okay, so the short version of this is that there is a really great way to get a very, very full-featured open source framework, and that's to have a bunch of venture capitalists fund a company, try to build something, then make it open source, try to make some money out of it, and as 99% of them do, fail. Don't get me wrong, I would love to open source Anvil, but the market has busily shown us, I used to say that the market has been busy showing us that there is room for precisely one large successful open source company, and that's Red Hat sponsors today. Only even they got bought by IBM a few weeks ago. So it is very, very tough. Look at Docker, right? Docker have transformed their industry, and they haven't made a profit. They make basically no revenue because their value ends up getting captured by commercial offerings on top. So I would argue that, in fact, it being a paid product and the fact that we are, in fact, a profitable startup means that it is likely to stay around longer than your average VC-funded open source project. And you're going to need some kind of funding if you want to build something this big. This was not a small undertaking.
If I may do a follow-up here, have you considered taking other forms of financing like grants, like Jupyter did, or other business models that would make these, that would help you also take off more and trust?
Yes, we have considered it. We have decided that they do not, in fact, help as much as we think we did, and I don't want to get into spend the rest of the day talking about that.
The next one, is it possible to run Anvil on own servers or locally?
Yes, absolutely. It goes Docker Compose pull, Docker Compose up, and then you have a whole version of this running locally. There's also the intermediate step. I showed you the uplink. If you have something local, you have a local database that's sensitive, but you want to expose just like 1 or 2 queries on it, that's fine. You can write an uplink script that has a function that will perform the 1 or 2 queries you want to expose to your web app and keep the rest of your data private. But as I say, if you need all your data on site, that's fine. We have on-site stuff. Come talk to me afterwards.
So you can run on-prem. Fantastic. What about the performance of this approach?
That was asked at a particular point during the talk, and I can't remember what exactly it was talking about. So obviously, compiling Python to JavaScript is less fast than writing it directly in JavaScript. Sculpt takes this hit to provide a better Python emulation, right? You saw when I was compiling that string object, it was a Sculpt built-in string object. I wasn't using JavaScript strings. That is so that we can preserve the Python semantics. In practice, execution speed of the stuff that's running in the web browser is not usually our limiting factor. Ultimately, of course, we're in the long term, once we're still waiting for a couple more things in the browser, but in the long term, Sculpt is probably going to shift to targeting WebAssembly, at which point it will be plenty fast. Of course, on the server side, if that's what you're asking about, it's just CPython, right? It's got all your standard extensions. It runs like greased lightning.
Who's your target group? Who is this product meant for? Do you have some larger examples of Anvil being used in production?
Yes, we do have examples. No, I can't talk about them in front of a crowded audience. I cannot tell you how frustrated I am that I cannot drop some names here. Yeah, so it's difficult to say who's it meant for because, of course, a programming tool by its nature is widely usable, right? We have people using Anvil everywhere from schools using the free version. We have everything you've seen me do in today's demo can be done on the free version. So there's schools using the very capable free version. There's hobbyists. There's individuals working on building their own projects. People building startups. People who have built startups on Anvil and now have millions of dollars and a team of people. And there are big companies using internal tools, using it to build internal tools. I can't use an example on video. And truly huge companies who are sufficiently paranoid that they need the on-premise installation. Yes, there are big companies. I'm sorry, I cannot name them, especially while that video camera's running.
Are you ready to take a couple more?
Well, yeah, sure.
Cool.
We still have nearly 4 minutes.
You said that you are converting Python code to JS. Isn't this also some kind of magic you mentioned before as a bad approach?
So I specifically qualified as the wrong kind of magic. And the wrong kind of magic is something like an ORM. It's a really good example of this, although JavaScript frameworks do the same thing. The thing that makes that magic dangerous is that it abuses the semantics of the layer you're working on to represent an adjacent layer, right? That book.price at less than 20 was not a numerical calculation. And if you tried to think about it like a Python programmer, you're going to come unstuck. Fundamentally, if you want to use something like SQL Alchemy in production, you're going to have to understand Python and understand SQL and understand how SQL Alchemy does the translation. It is a very, very leaky abstraction. This is not true of a compiler, right? I do not need to understand how CPython works to write Python. I do not need to understand how Sculpt works to write Python. I do not need to understand JavaScript to use Anvil. And so this is a kind of abstraction we will stand behind.
Can you give some example of a real website built by Anvil? Or maybe a couple of websites?
Pardon?
Maybe a couple of websites or web apps?
So there are some out there. Again, I'm really annoyed because obviously a lot of the biggest projects here are internal tools of companies that I can't show you even though they are really cool. There's a startup called Lightning AI which have given us permission to use their names. They have like an ad tech serving platform. Actually, they're a perfect example. It was a data scientist, a Pythonista with a maths masters who wanted to build an ad tech product. She had the statistics. That was her thing. She didn't have the full stack web capability. It was going to cost her the best part of $100,000 to get someone to build just the first prototype, and everybody knows the first prototype is not what you're actually going to want to ship. Instead of which she grabbed this and built it herself. Lightning AI is the thing to Google if you want to find them.
There's more than a dozen more questions, so...
Well, yeah, let me know when I run out of time.
Okay, if you'd like to continue, there's one question which is kind of hard to understand. Can you show us the client HTML source of that example? So, by the way, if I may, yes. when you write like things like that example, it's useful if you refer to a specific example so that folks know.
I don't know which example you're talking about, so I'm going to show you something generic. Come find me afterwards if there was something you meant something else. So, a really important thing about Anvil, and the reason that the things that make it powerful enough for seasoned professionals is that there's always an escape hatch to the low-level, high-powered tool, right? One example of this I didn't talk about is version control, right? Every Anvil app is a Git repository. I can check this out with Git and work with it on my local machine. It is properly version controlled. And another of these escape hatches that let you use the power tools is that you can drop down and edit HTML and JavaScript and CSS. So here's an example. I'm going to go into the assets of my page and I'm going to edit the HTML. Now, the crucial thing here is that we are not editing the HTML that comes out of Anvil. We are editing the HTML that goes in. And what that means is that when I make a change here, I have not broken my abstraction. I can edit this HTML and then go back into the drag and drop designer and I can still use it. You don't offer them the choice between easy for novices and powerful for seasoned pros. You offer them both at the same time. So You saw when I started up, I chose like my visual theme and I chose like a Google Material Design theme. This is the HTML and the CSS that implements that theme. And I can go in, I can edit it. If you go onto our user forums, you can find lots of examples of people editing it to their satisfaction or creating like a company house style. But again, anything you edit here will show up in the designer, and you can still use the power tools alongside the easy-to-use stuff.
Okay, fantastic. So let's give a hand to Meredith.
Thank you very much.